Hi, welcome back. This is out of the Math 1 book, page 91, numbers 1 through 15. It says factor the polynomial, and the first thing that I notice is that these are going to give us different factoring situations. For example, this one only has two terms, and it has a difference. So I'm going to look to factor that using the difference of squares. Number 2, also the difference of squares. Number 5, although you may not see it, this is a difference of squares because that negative sign and a positive sign. And also there's a GCF in this before you do a difference of squares. Number 7 is just simply factoring a trinomial. This is called a perfect square trinomial. And basically, I just tell people to factor this the same way you would any other trinomial. What multiplies into 144 and adds up to 24. And then number 8, it appears to me that there is no greatest common factor. That's what you want to look for first. And number 8 is going to ask us to do a Lizzie method. Okay? And then on the back, we have a Lizzie method again, another possible Lizzie method. This is just factoring a trinomial and another trinomial. So we don't actually get to use the factor by grouping, the factoring with 4 terms. So this is only binomials and trinomials. Just before making the video, I made some notes. There are 4 factoring techniques. First one that you always look for is the greatest common factor, GCF. You see if there's any number the same between all 3 or 4 terms, or even 2 terms. The second bullet is a binomial. Anytime you have a binomial, something with just 2 terms, you look for the difference of squares. I should repeat myself. You look for GCF first, even if I tell you to do all these other factoring techniques. You always look for GCF first. And then if there is a difference, you do difference of squares. Trinomials. And basically, it could look 2 different ways. It could look with it could have a 1 out in front of the x squared, so x squared plus bx plus c. And you just ask yourself what multiplies up to c and adds up to b. Okay? And then, if there is a number other than 1 out front, I guess I should put an a out here, out front, here. I just don't want you to be confused. And this is where a equals 1. So either a can equal 1 or a is not 1. If a is not 1, you have to do the Lizzie method, which I've walked through a number of times, but maybe haven't specifically told you how to do it. Basically what you have to do is you take the a and the c and you multiply those together, rewrite it as x squared plus b plus ac, and then factor that the same as you would a trinomial where a is equal to 1. And then a polynomial with 4 terms, you're going to be factoring by grouping. The steps to do this are group, and then GCF, GCF. However, we won't be getting to that 4th type of factoring in this lesson on numbers 1 through 15. So anyway, on number 1, it is a difference, and these are perfect squares. So x minus 6, x plus 6. 6 times 6 is 36, so 6 is its square root. And also x times x is x squared. So x is this one's square root. Okay, and that's all there is to it. Now I have a number out in front of the p squared. So what I'm going to do is just make sure to take that square root as well. This is going to be 5p minus 12. 5p plus 12. You have 12 times 12 is 144. 5p times 5p is 25p squared. Okay? You just have to memorize this. There are 2 options here. You can either rewrite this in the opposite direction, or you can factor out a negative 2, and I like to do that. I'm going to factor out a negative 2, and I'm going to end up with x squared minus 16. So I'm going to leave that negative 2 out here, and then I'm going to factor the x squared minus 16 into x minus 4, x plus 4. Alright? Number 7. What multiplies up to 144 and adds up to 24? I think you can think of that pretty quickly. Y plus 12 times y plus 12. Now, if these things repeat, if the factors repeat like this, you can always write it like this. Y plus 12 squared. Okay? And number 8, Lizzie method, because there is no common factor, so 9 times 16, I'm going to do that in my calculator. 9 times 16 is 144. C squared plus 24C plus 144. Well, now think of this. This is the exact same question as number 7, except for that it's using C instead of Y. So it's the exact same method. So here we are. We're going to say C plus 12 times C plus 12. Now, we don't stop here, though, because we had that 9. We're going to have to divide by 9. 12 divided by 9 can be reduced because 3 goes into both numbers. This is 4/3. C plus 4/3 times C plus 4/3. Okay, remember to write the 3 out in front of the C, so 3C plus 4 times 3C plus 4. Now, any time in the problem, you could have just written this one time and squared it. I'm going to choose to do it right now. 3C plus 4 squared would be your final answer. Okay? A lot of people, I wouldn't mind if you left that factored in factor form, 3C plus 4 times 3C plus 4. But if you wanted to write it like this is a good way to write it.